Hey everyone, Radzien here. In this video, we'll build an interactive chart that overlays your ETH trade history on price data using React and TypeScript. We'll use the RadzionKit TypeScript monorepo boilerplate to jumpstart the development with pre-built utilities and components. And if you're interested in the complete source code, you'll find the link in the description. Our application serves as a unified dashboard for tracking ETH trading activities across multiple UVM-compatible blockchains and wallet addresses. At its core, we define a trade with properties like the amount of cryptocurrency involved, the traded cryptocurrency, whether it's ETH or robbed ETH, the stablecoin used for payment like USDC or USDT, the exchange rate at the time of execution, the trade direction, buy or sell, the timestamp of the transaction, and the unique transaction identifier on the blockchain. In a previous video, we covered how to create a trading history tracker. You can find that video in the description. Today, we'll focus on visualization, crafting an interactive price chart with trade overlay capabilities. The journey starts with the trades chart component, which takes an array of trades as input and transforms the data into an insightful visual representation. To create the price chart, we need historical Ethereum price data. We fetch this using a custom hook that gathers time series data based on the asset ID and the required time range in days. This range is dynamically calculated from the earliest trade timestamp to the present, ensuring we have enough data to display all trades on the chart. For retrieving historical price data, we use CoinGecko Market Chart API. The function responsible for this task accepts parameters like the asset ID, for example Ethereum, the fiat currency for price denomination USD by default, and a time range in days. It then fetches and transforms the data into a clean format, ensuring compatibility with our charting components. To handle the data fetching process, we use the match query component from RadzionKit. This helps manage the lifecycle of our charts rendering, ensuring appropriate UI elements are displayed depending on whether the data is loading, successfully loaded, or encountering an error. This approach guarantees a smoother user experience, avoiding unwanted flashes or error states. Once we have the trade and price data ready, we use RadzionKit's specialized charting components to render the visualization. While we won't dive into the details of these components here, if you're curious about building a line chart from scratch, I've covered it in another video linked in the description. For optimal y-axis labels, we use a function that calculates step sizes, ensuring the scale is clean and readable without overcrowding or sparse labeling. Then to standardize the visualization, we normalize all y-axis values to a range between 0 and 1, maintaining relative relationships across data points while simplifying the rendering. To overlay trade data on the chart, we use a custom component that represents each trade as a hoverable marker. Buy and sell transactions are visually differentiated using distinct colors and icons. When users hover over a trade point, a tooltip displays detailed trade information in an elegant overlay, enhancing the user experience by providing quick access to transaction details without cluttering the main interface. So in this video, we've built an interactive trade chart that combines price history with trade execution data. Using RadzionKit components, we created an intuitive visualization that helps users understand their trading history in the context of market conditions. This approach can serve as a foundation for building other data-rich applications. If you found this video helpful, give it a like and don't forget to subscribe to the channel for more tutorials like this. See you next time.